Welcome to the second video on my YouTube channel. Today we are diving back into the fascinating world of brewing with a focus on brewing equipment and its practical application. In this video, I'll share the modification I've made to my brewstand to simplify water dosing for home brewing. This project began when I set out to find a more efficient way to measure the exact amount of water needed for brewing. My initial idea was to use the fill-o-meter from Keglan, which you can see here on the right-hand side of the screen. However, before placing the order, I realized that it wouldn't work for my setup. The fill-o-meter is only accurate with the flow rates between 1 and 30 liters per minute, which is higher than what my RO water system can deliver. I typically mix my brewing water by combining RO water with tap water to achieve the desired bicarbonate levels and then adjust the concentration of other minerals as necessary. Unfortunately, the fill-o-meter would only allow me to measure the tap water portion of my brewing water, leaving the RO water unaccounted for. That's when I came across a solution. While browsing an online auction, I found a scale shown here on the screen and decided to design a system where I could weigh out the water instead. This approach eliminates the need for the large 5-liter measuring jug that I've been using up until now. On the left side, you can see what we will cover in this video. The build, a detailed walkthrough of how I modified my brewstand, a demonstration testing the system to show how I measure water by weight, a mass balance in brewing, exploring whether this system has other potential applications in brewing, and my final thoughts, wrapping this video up with conclusions and consideration. Lastly, I want to make it clear, this video is not sponsored. Every piece of equipment shown here was purchased with my own money. Here's a photo of the scale I purchased, taken outside my house in the driveway. The scale is rated for up to 200 kilos, which is more than enough to handle my brewing setup, even when it's fully loaded. It displays weight in kilograms with 2 decimal places and increments of 0.05 kilo, meaning its accuracy is plus minus 50 grams. This level of precision works perfectly for my needs and is far superior to repeatedly measuring smaller volumes using a 5-liter measuring jug. To modify the scale for my brewstand, I started by removing the display. This involved disconnecting a small 4-wire plug. On the scale side, I also had to remove the 4-wire plug so I could thread the cable out from the arm holding the display. This step took some time as the wires were secured in place with hot melt glue. After some effort, I successfully freed the wires, with only one requiring resoldering. With the wire removed, I cut off the display arm using an angle grinder. Next, I measured and drilled 4 holes into my brewstand to securely fasten the scale frame. I used the existing threads where the scale's legs were originally attached. Additionally, I drilled a hole in the brewstand to route the display cable through it, allowing the wire to exit through a large pre-existing hole on the side of the brewstand. Finally, I placed the base plate back on top of the scale. The base plate isn't physically attached, but simply rests on the top of the frame. In the future, I plan to replace this with a stainless steel plate for added durability and longevity. For now, however, the original base plate will have to suffice. I also plan to have the mounting bracket made so the display can be securely installed over the large hole in the side of the brewstand. For the time being, I'll simply move the display along with the brewstand whenever I need to use it. After assembling the system, I proceeded to test it. On the right side of the screen, you can see the preparation of brewing water. First, I measured out the required RO water, followed by tap water, which I added using a PE hose. As shown in the video, the system makes it incredibly easy to reasonably accurately dose the required amount of water. In the test shown, I was aiming for 39 kilos of water. Since the system performed so well, I decided to purchase an additional scale for my sparge water heater. This second scale can be seen here. It has a maximum capacity of 150 kilos and displays weight with 2 decimal places using increments of 0.01 kilo for even greater precision. With these 2 scales, I can now track the weight of both the water and the malt going into the brewing system with precision and ease. To see what else I could use this new weight system for, I decided to set up a mass balance for my brew setup, hereby trying to calculate other values important for my brewing process. The overall mass balance for the system can be set up like this. So what is coming into the system is of course equal to what accumulates or stays in the system plus what comes out of the system. And in case of the brewing system here, what comes in is the mash water or the brewing water plus the sparge water and of course the malt. What stays or accumulates in the system is the wort, which is of course a combination of water plus extract. And what is coming out is the water in the spent grains itself, and the water that evaporates during the process. I tried to measure the water that was lost due to evaporation. However, using this system, I couldn't measure any evaporation, meaning that the sensitivity of the system was not good enough to detect the amount of water lost. Therefore, this amount is negligible, and I can therefore remove it from the equation. Using this weight system, I can measure what comes into the system, I can measure what accumulates in the system, and I can measure what comes out. Meaning, even though I was missing one of these measurements, I would be able to calculate the missing measurement based on this equation. So the overall mass balance equation, as can be seen here, is of course important, but as we can measure all the different values, it doesn't really give us any new insight to the system. However, we can also set up mass balance for the different components of the system. For the malt, we can set up a mass balance showing that the amount of malt coming into the system is equal to the amount of extract in the brew pot combined with the weight or mass of the spent grains coming out of the system. Similar for the water, we can set up a mass balance showing that the mass of the water, meaning the brew water, and the sparge water is equal to the amount of water or weight of the water in the brew pot, together with the water absorbed in the spent grains. It can be seen that these four values that we are really interested in, meaning the mass of the extract, the mass of the water in the brew pot, the mass of spent grains, and the mass of the water plus spent grains, cannot be calculated based on these equations, since there's too few independent equations. However, what can also be seen is that the mass of extract and the mass of the water in the brew pot is of course equal to the mass of the wort, which we can measure. We can also see that the mass of the spent grains plus the mass of the water in the spent grains is of course equal to the total mass of spent grains and water that we can also measure. Then this is how the individual mass balance equation is connected to the overall mass balance equation. But since we cannot really determine any of these four values, we need to determine one of them, and from that single value, we can calculate the rest of the three values. Of these four values, the mass of the extract is of course the easiest to determine, as it is quite often done in home brewing. This is normally done as specific gravity, but in this case, we are more interested in the actual mass of the extract. However, this can be converted from the measurement of specific gravity using different equations. There are several of these available, and I have just chosen one here, and this is the one from the Brewer's Friend webpage. And you can see this polynomial where you plug in the specific gravity and you get the degree Plato. The degree Plato tells us the amount of extract that is in 100 grams of solution, meaning as we know the degree Plato from the specific gravity, we can multiply it by the mass of the wort divided by 100 grams, and that will give us the mass of the extract. As soon as we have measured the amount of extract using a reflectometer or a hydrometer, we can of course then calculate the three last values. And this is done using these three equations. So first, we can calculate the mass of water in the brew pot using that we know that the amount of wort we have measured minus the amount of extract is equal to the amount of water in the brew pot. Similarly, we can calculate the mass of the spent grains using this equation, saying we know the amount of malt, we measure that using our scales, and then minus the amount of extract is equal to the amount of spent grains. And finally, the mass of the water in the spent grains is of course equal to the mass of the spent grain plus water, which we can also measure using the scales, minus the weight of the spent grains. So by measuring the weight of the malt and the weight of the water coming into the system, and either the weight of the wort accumulating in the system or the weight of the spent grains plus water coming out of the system, together with the measured extract, we can determine all these variables. So what can we use these for? The only thing that I found that could be useful to use these values for was actually to calculate the absorption of water in the spent grains. So normally this parameter is used by homebrewers to calculate the amount of sparge water needed to reach a certain volume. Here we see that if we know the amount of water in the spent grains and we know, of course, the weight of the malt that we put in, we can calculate the kilo per kilo of water absorbed in the malt, or even in liter per kilo if we assume the density of the water to be 1. I don't think this is going to change much for me, at least in terms of my homebrewing, as I normally just tend to overspart slightly. However, if there's something I have missed or any other value or parameter that you think I can calculate based on this new setup, please let me know in the comments below. Also, please let me know if there's any other brewing application where this system could be useful. I was fortunate enough to find a 200 kilo scale at an online auction that perfectly matched the size of my brewstand and could be easily disassembled and reassembled into this setup. This was especially helpful since I'm far from an expert in electronics. I'm sure that someone with more expertise in electronics could create a more elegant solution using a load cell like the one showed here, paired with a microcontroller. I'll include a link to the load cell in the video description. If, like me, you are not particularly skilled with electronics but still want to build a similar system, I found this scale shown here on Amazon that closely resembles the one I used. A link to the scale will also be in the description of the video. While I can't confirm it is exactly the same model, it's worth noting that my brewstand was purchased from an industrial kitchen outlet. Chances are you'll need a different size to suit your own brewstand anyway. Be sure to double check if the scale you choose is compatible with your setup. If the size isn't a match, you might still be able to repurpose the load cell and display, as these typically come with the required electronics already integrated by the manufacturer. Overall, I'm thrilled with how much simpler and more efficient my modified brewstand has made preparing my brewing water. I hope this video has been both helpful and inspiring for your own brewing journey. Thank you for watching. If you enjoyed the video, please consider liking and subscribing.